This is problem 1 on practice exam 2 of chapter 1 in the book Problem Solving Guide for Differential and Integral Calculus. The normal equation that relates base and height of a triangle to the area equals 1/2 base times height. You probably know that one. What is the difference equation that gives the area change delta A when B is changed by delta B and H is kept constant? So let's consider two triangles, that one there, base B, height H, and a different one whose base is different by delta B. So this increase in base, delta B. What's the difference in the area between these two triangles? Delta A. Well, the area of the big triangle is 1/2 B plus delta B, that's the base, times the height, and we subtract the area of this triangle, which is 1/2 base times height. We can distribute the H through some algebra. We have 1/2 base times height here, minus 1/2 base times height here. Now what's left is 1/2 delta B H, and that is delta A. And we can draw this line, and we can see where it comes from. The area of this long, thin triangle here is delta B times H divided by 2. And this is the difference in the area. So it's not surprising that the formula is 1/2 delta B times H. It makes sense. On to part B. What is the difference equation that gives the change in area delta A when B is changed by delta B and H is changed by delta H? So now both are changing. Again, two triangles. This one's got a height difference of delta H and a base difference of delta B. The area of this one, just like the area of any triangle, is 1/2 base times height. And the area of the big triangle, 1/2 base, which is B plus delta B. The height is H plus delta H. And we subtract the area of this one to get the difference. We're going to have to multiply this out. First is base times height, outers B delta H, inners delta B H, and lasts delta B delta H. So we have that. There's a minus 1/2 base times height. There's a plus 1/2 base times height. We're left with this, and that is delta A. That's the formula for delta A between any two triangles with a base difference of delta B and a height difference of delta H. On to part C. Here we have some numbers. We have one triangle, base of 10 centimeters, height of 5 centimeters. Another triangle, base of 10.1 centimeters and a height of 5.02 centimeters. We're going to use the normal equation to get the area of each of those and then subtract the areas to get delta A. So the first triangle, 1/2 base times height, that's 25 square centimeters. That's the area of the first triangle. The second triangle, 1/2 10.1 times 5.02, and we get 25.351 square centimeters. The difference is 3.51 square centimeters. That's delta A. Now we're going to use the difference equation. Part D asks to get the difference equation. Use the difference equation to get delta A, and we derive the difference equation in part B. There it is. So we have a B of 10, a delta B of 0.1, an H of 5, and a delta H of 0.02. And we get each one of these. There's 0.1, 0.25, 0.001. This is the nonlinear term. It has two deltas in it, delta B and delta H. These are the linear terms, delta B and delta H. And if we add those three up, we get 0.351 square centimeters, which is the same answer we got by using the normal equation twice and subtracting the area. That's problem 1.